Hello everyone. Today we will be going through some LeetCode problems. This is the first video of my Road to LeetCode Mastery series. And today we'll be going through some binary tree problems. Everyone's favorite topic, I know. And yeah, I'm just going to be walking through my thought process, how I approach different problems, different ideas I have. And yeah, should be a good time. My coding language of choice is Java. So that is what I will primarily be using. And yeah, without further ado, let's get right into it. So the first problem, hold on, So the first problem that I will be doing is LeetCode 508, most frequent subtree sum. All right, let's take a look at this. I am going to share my screen. Give me 1 second. All right. Okay, so first of all, let us read the problem. 1 second here, getting situated. It's going to be a long road to LeetCode Mastery, so buckle in for the ride. I'm going to get the handy dandy scratch paper out, just in case. You never know. You never know when you gotta draw a few edge cases here and there. All right. So let us take a look at what we have. Number 508, most frequent subtree sum. Given the root of a binary tree, return the most frequent subtree sum. If there is a tie, return all the values with the highest frequency in any order. Okay. So the highest frequency in any order. Got it? The subtree sum of a node is defined as the sum of all the node values formed by the subtree rooted at that node, including itself. Okay. All the node values formed by the subtree rooted at that node, including itself. All right, let's take a look at an example. So here we have a 5 as the root. The left child is 2, the right child is -3, and the output is 2 because, let's see, the sum of all the node values formed by the subtree rooted at that node. The sum of all the node values, including the node itself. So wouldn't it be 7 minus 3, which is 4 in this case? Why is this 2 here? Hold on. See, step 1 to any problem, folks, always make sure you understand the question and read through the example cases. Otherwise, I promise you, you're not going to get anywhere. All right, so let's reread it. No harm in rereading it, you know? Given the root of a binary tree, return the most frequent subtree sum. Most frequent subtree sum. Oh, okay, I think I'm starting to get it. If there's a tie, return all the values with the highest frequency in any order. All the values with the highest frequency. Got it. I think. No, I don't got it. Because why would we return a 4 at this case? All right, hold on. Let me look at example 2. Make things a little easier. So we have 5, 2, and then -5, right? 5 to -5. So the sum at the root is 2, because 5 minus 5 is 0 plus 2 is 2. And then the node on the left, the left child of the root, the sum is just 2. And then the node on the right, the sum is just -5, right? So then return the most frequent subtree sum. So there's 2 2s and 1 -5, so that's why I return 2 there. Okay. And then for the first one, at the root, we have a 4 subtree sum. The subtree rooted at the left node has a subtree sum of just 2. And the one on the right is just -3. Oh, so that's why we return 2, -3, and 4, because okay. Because those are they're each sum only has a frequency of 1, so we return all of them with the highest frequency in any order. In any order. Oh, okay, got it. In any order. Okay, that makes it easier. Okay, I'm understanding the problem now. It's making sense. Okay. So let's think about how we want to do this. So we want to okay. So let's initialize a okay, we don't know how many. We don't know what the size of the array that we want to return at the end might be yet. So let's initialize an array list. And let's actually do this here. So it's a global array list that any helper functions we create could reference. And then actually, before we even do that, let's take a look at the constraints here. The number of nodes in the tree is in the range 1 to 10 to the 4. Okay, so if the root is equal, or actually, so if root.left equals null and root.right equals null, right? Like they only give us one node, then we can just return, sorry, people are sending me messages, I'm gonna mute that. We can return an array with just the one element in it, which will be root.val, and that should be good. Otherwise, if there's more than one, well, we're going to have to create this helper function, which is going to populate our global integer array list. And then at the end of this, so we're going to call helper function here to populate global array list. And then after that, we're going to convert contents of list to integer array. So we can call this recursive helper function add sums. It's going to take in a tree node. And then, okay. I don't think we need to pass anything else into it since we already have that global array list. So we're going to call our helper function here. We'll pass in the root. This is a void, so it's not going to return anything. And then here, we're ultimately going to, we're going to initialize a new array, which is going to be the size of our array list. And then for each number in the array list, we're going to, actually, we're going to have to do this, aren't we? A long way. This is why Java is annoying, folks, because everything takes takes a while to type out, even the mundane tasks like this. So rep array I is equal to okay, and then we should be good to return the rep array here. Okay, so I'm trying to think for a second if we should filter out. Wait, actually, you know what I'm realizing, folks? We might need a hash map that stores the frequency of subtree sums. And then we would iterate through the hash map, and if we'd find the max, what is it? Oh yeah, we'd find the most frequent sum, or if there's multiple most frequent sums, and then we'd add it into the array list. So technically, we could just initialize this here. We can initialize this here, and then how do I want to do this? Remove. I'm thinking. Okay. So let's scrap this. And what we're going to do is we're going to have like a hash map to update frequencies in a hash map. And then what we're going to do is like iterate through hash map frequencies and count the number of max frequent sums. And then that's going to be the initialize rep array with this size and populate it accordingly. Okay, something like that. So we can comment this out for now. Okay. Yeah, in the beginning, it's always a bit of a little bit of a learning curve to it. Sometimes you think about it as you go. Other times it's better to just plan from the beginning and not code. But either way, we'll get there in the end, folks. So, okay, so what do we want to do? We're going to initialize this hash map in here. All right, now we have a global hash map. Now we're going to call add sums, and this is going to populate our hash map with the frequency sums. Okay, let us do this helper function. So how do we want to do this? We're going to want to recurse and get some from left subtree, and then same for right subtree. Add these two values with the current root dot value, and add this to our frequency hash map. And then I don't think we need to return anything because it's void, right? Okay, I think that's good. So what's our base case? So if we come across a, oh, you know what? I'm actually going to change this to nodes. Sorry, folks. So if we come across something that's null, we're just going to return because we don't. Hold on. So actually, this has to be an integer helper function because we want to return. Otherwise, we want to return like the sum in the left subtree and the sum in the right subtree, right? So actually, if node is null, we can return 0 because there's no value there. Otherwise, if node is not null, then we can initialize our values like this in sum. And left sum is equal to add sums of node dot left, and then similarly, in right sum is equal to add sums node dot right, and then okay. Or sub tree sum is going to be left sum plus right sum plus the node.val that we're on. And now here's where we're going to populate the hash map. And we're also going to return this. So populate hash map here, and then we're going to return subtree sum because we need to pass that value back up the tree. So here, all right, we're going to do this check or put, and then, okay, let's think about this. There's a shortcut that allows you to sort of like keep a hash map as a frequency counter, and it's pretty nifty. And that function that's going to allow us to do that is hold on, I'm pulling up the name. It's .get or default. So an easy way to start a counter is like we're going to put in our subtree sum, and then we're going to do frequency.get or default subtree sum 0 plus 1. And so what that does is it's going to look in the hash map. If subtree sum doesn't exist, like this is a new key that we're adding, it's essentially just going to treat it as if we were getting a 0 and then we're adding 1 to it. So because we're incrementing the counter right from 0 to 1. Otherwise, it'll get the value that's there if the key already exists and just add 1 to it and put that back in the hash map. So that should be good. Okay. It's looking good so far. So now we're going to iterate through the hash map frequencies. So let me think about how I want to do this. Okay. First, I need to iterate and get the max frequency, right? Max frequency sum. Okay, so for integer sum in freq.get keys. Hold on. Is that not? Oh, it's key set. Freq.key set. Is it .get key set? No. Hold on. Let me think about this for 1 second. So we're putting, okay, in the hash map, we're putting in the sum and how many and the frequency of that sum, right? So first of all, when we initialize this hash map, we want to see which sum is the most frequent, or sums are the most frequent. So what we're going to do is, we're going to get the max frequency out of any of them. So we're actually going to iterate through the values. Values. Actually, I believe this is a lowercase. And then we're going to set max frequency is math.max, max frequency, and this is actually a misnomer. So, what do I want to call this? Curve frequency. Okay. So now that we get the max frequency, we're going to iterate through. Well, now we need to count how many of those have that. I'm trying to think if there's a faster. I'll think about performance afterwards. Think if there's a faster way to do this or not. So let's go ahead and not max frequency, but the int max frequency count. So how many unique sums, right, have that. So we're going to iterate through the keys and the key set. And if frequency dot get key is equal to our max frequency, then we are going to update the counter like that. Okay. Then at the end we have an array list that we're going to initialize with that size. You know what, folks? I don't like this. You know what I'm going to do? Because if I create an array, I'm going to need to go back through the values again to extract the sums again to extract the keys. So honestly, guys, I'm just going to do an array list and convert it at the end, because it's just too much work. New array list. So I'm going to try and speed up a little bit here because we're off to a little bit of a slow start. My bad. All right, so what we're going to do is we're going to forget this max frequency counter. We don't care about that. If the frequency.get is the key, we're going to add it to, we're going to add the key because that's the sum into our array list. And then we're going to return, let me see if there's a quick A quick way to convert a integer array or an integer list into an integer array. Collection, start retain all. I'm looking. Dot to array. Oh. I found this fancy function, guys. Y'all think this is gonna work? If that works, I'm gonna be impressed, actually. Fancy function for the win. Can I get can I get some prayers in the chat? All right, run that code. Can't find symbol ret. Yep, because I didn't initialize it before, like a smart one. What about now? Hey! All right, don't get too excited. That was just one test case. But honestly, I'm confident. Oh, yeah. Faster than 22%. Let's get it. All right. We cooking. See, listen. I told y'all, I get off to a slow start, but don't let me cook, all right? Don't let me cook. Because once I get in the groove of things, man, don't mess with Mike, all right? Don't mess with me. All right. So we got that running. Let me take a little pause, drink some water, stay hydrated, folks. Delete some comments, all right? We're gonna tidy up this code, and I'm also gonna think if there's a way that I can make this more efficient. All right? Hang in there. Don't go anywhere now. Don't leave your boy hanging. All right. Give me 1 second. All right, let me take a quick drink and a quick think. I'm on to something. Okay. I think that I can get rid of this if I instead, when I do this, so I'm going to keep a global integer, which is essentially this. It stores the max frequency. And as I'm adding new frequencies to the hash map, I will check, hey, does this pass the current max frequency? If it does, just update it so that when I get out of that loop, I'm going to have a global variable that already has this. So I don't have to iterate through it again. So I'm going to do this. Sometimes it's good just to take a pause after you coded. Just try and digest what you just wrote and see if there's a better way to do it. Oops. Yeah, this should be good, I think, guys. It's not good. I'm thinking. Why are you not running right? I didn't do anything fancy here. I just. Oh. Oh, guys. You gotta initialize it before. There we go. 44%. All right. Honestly, I'll take it. Let's take a quick peek at the solutions. See if there's anything better. No. Yeah, they're honestly doing the same thing that I did. So, yeah, we'll take that. We'll definitely take that. All right. So that looks good. I can share my screen for this. Let me share my screen. Oh, let's just go with the window, yeah? Oh, hold on. Entire screen? Ooh, entire screen might be a little risky, folks. What are we thinking? All right, you know what? Give me 1 second, folks. I'm just going to record this problem in my notes. All right? Because what I tell people is that whenever you solve something or you learn something useful that you think, might help you in the long run to remember, write it down. Not only does it help you, not only does the physical act of writing it down help you remember it, but it can be like a log for all the work that you've done. And hey, if you come across a similar problem in the future and it looks similar, boom, you have that solution written down. Instead of looking through all the code that you just did, you can just take a quick peek at, hey, what is this? What was the summarized version of how I solved it? And then that can give you ideas, and you don't waste that extra time. So I see it as an investment, right? That you're taking a little extra time to write that down right now, but in the long term, that's going to help you out. So that's why I recommend doing that. And honestly, it might just be good just to recap. What did we just do for people just joining in? How did we get that working? How did we solve that problem? So this is how we solved it. First step, create a global hash map to store some frequencies. Then we wrote a global integer to store the max frequency. And then call a recursive helper function that finds the sum of the left and right child subtrees and adds it to the current node.val. Then populate hash map with this sum and add 1 to its frequency. Check to see if this frequency is new max frequency. If it is, update it, and then return current sum. And then back in main function, you what do? You initialize an array list, initialize a list, and add all the sums which have a frequency equal to max frequency, and then convert list into integer array and return. Sweet. See, just two minutes or so, and it'll set you up big time for the future. All right, let's take a look at the next one. The next one we will be doing. All right, we're going to be doing this one. Share my screen. Boom. Okay. Wait a minute. Oh, I've done this one before. Okay, you know what, guys? We're not going to do this one because this one's easy, all right? It's too easy for your boy, all right? Put some respect on my name. So, yeah, I guess I'll describe it real quick. So you can do a level order easily to iterate through the levels of a binary tree with the queue. And so if you just find the largest value in each row, you can literally just, using this while loop and a for loop to like iterate through the current size of the level, you can just keep track of the current maximum of that row, add it to a list, and then return the list at the end. Hooray. All right. Well, that was a quick one. Okay. Next problem won't be as quick. Another LeetCode medium here, number 655. Print binary tree. Okay. I see you, LeetCode. Oh no. God. All right. What does it want from us? Return the root of a binary tree. Construct a zero index m by n string matrix res that represents a formatted layout of the tree. The formatted layout matrix should be constructed using the following rules. The height of the tree is height, and the number of rows m should be equal to height plus 1. So, okay, so if you have like 3 nodes, 0, 1, 2, so, okay. The height of the tree is just, wait, but why is it, oh. I think they consider the height of a tree to be like 1 in this case. And then that's why there's 2 rows in the array. Okay, got it. The number of columns should be equal to 2 to the height plus 1 minus 1. So in this case, it will be 3. 1, 2, 3. Oh, yeah. Because there's 3 possible places you can add it. And then place the root node in the middle of the top row, more formally at location res 0. 0th row, n minus 1. What's n? Oh, n minus 1 divided by 2. Yeah, that makes sense. And for each node that has been placed in the matrix at position, place its left child at, okay. Okay, I see what's going on here. So you just envision it like a grid, and what are you putting, the values of the nodes in there, I assume? Continue this process until all the nodes in the tree have been placed. Any empty cell should contain an empty string. Return the constructed matrix. Wow. Okay. Huh. Not gonna say I'm panicking, but your boy's panicking. Oh man. So that's one. Wait. 1, 2, 3, 4, 5, 6, 7. Oh yeah. Hold on. Number of columns is equal to 2 to the 3, so 8 minus 1 is 7. Why is it 7 in this case though? 1, 2, 3, 4. No. So if this had a node, it'd be, and if this had a node and that node had children, it'd be 1, 2. Oh wait. 1, 2, 3, 4, 5, 6, 7. Oh. Okay, I get it. It's because these nodes aren't directly on top of each other in the, like they're not in the same column in the grid that we're printing or returning. Okay. Yeah, I can already tell this is going to be a mean one. So, all right. Well, let's start with what we can do. So first let's, okay. What do we need? We need the height of the tree. And we need okay, and once we have the height of the tree, we're chilling, okay? So int height plus 1. So wait. Okay, int height. We're going to do our favorite and create a helper function to get the height of a binary tree. Now, I am pretty comfortable doing this, I think. So if the node is null, return 0. Otherwise, return 1 plus the math.max. Wait, it's a maximum height, yeah? Yeah. Okay. And then get height of node.left. Get height node.right. Yo, you know what? Okay, guys. If I ever get to 100 people watching this stream at one point, I'm gonna try and find a way to get some live music, or not live, but play some music while I'm live. Because I think that would be fire. Like, I'm a big music listener. I love alt rock and hip hop. I got over 8K songs liked on Spotify. and I try and listen to an album like almost every day. So I really like taking recommendations and listening to people's stuff. So yeah. All right. We're 45 minutes deep into the stream. Let's go. It's getting lit up in here. All right. Lock in, Mike. Lock in. So what we're gonna do, all right? What we're gonna do is, did I implement this right? Yeah, I did. Okay. So we're gonna get our height. So let me do a quick calculation. So in this case, it would return 1 plus the max of these two, and that would be 1, so it would be 2. Oh, that's very interesting. Because technically, it would return 2 here. So actually, you know what I'm saying, guys? This is actually going to be m. Because LeetCode's definition of height is what this function returns -1. So yeet, and then, oh boy. All right, hold on. All right, we're going to do some quick math right now. Who's ready? Okay. So m is equal to height plus 1. So tau 2 m minus 1. This needs to be in an integer. And make sure that that's an integer right there. And so now we should be good. We should be good. Okay. So we got our grid. Let's go. Now, ladies and gents, this is where we must populate this grid. Which I'm trying to figure out how we're going to do. Okay. So what if we have okay, we're going to initialize this grid globally so we can access it from any helper function we want and update its contents. Okay. Next, okay, so we need a way to keep track of the row and the column we're on. Oh, wait a minute. Oh, I got it. Okay, so we're going to keep track of our x and our y. Our base cases are going to be like, make sure you're not null, make sure node not null, and not outside of bounds. And then what we're going to do, we're going to call this function on the root, and we're going to pass in exactly what it told us to pass in right here. So 0, because it's first row, and n minus 1 divided by 2. Yeah, because that's the length. Okay. Yes. This is good. This is good stuff. Okay. And then after our base cases, we're going to fill in cell at current x, y, or current coordinate, I guess. And then we're going to recurse left. And then, yeah, like, what is it? Subtract 1. Oh, yeah, add 1 to the x. And then we're going to, like, what is it? Like, C plus 2. I'm thinking. So if you start at n minus 1 divided by 2, what is C? Am I tripping? Oh, here we go. So if C is the y in this case, we're doing y plus 2 to the... Why isn't it just like y plus 1? Like, or y minus 1 if you're going left, y plus 1 if you're going right. That's what I'm trying to figure out. I mean, okay, so in this example, what would it be? Like, the height, 1, 0, minus r. Guys, this isn't easy. Okay. Oh, what am I doing? I want to recurse left first. So it's to the height, but that gives us, oh. Plus 1, minus 1. Okay. Cooking. We're going to keep track of int height Wait a minute. Guys, I'm getting confused with the indexing, I won't lie. All right, 1 second. I'm turning the AC on. It's getting hot in here. Come on, Nelly. Might be time for another swig of water. W water chat. You know what? Let me know in the comment section, all right? All 0 of you out there. Let me know. Is my camera in the bottom right corner suboptimal? If so, I will move it. But only when we get to like 100 viewers at a given time on the stream. Because if there's 17 of you out there, man, I ain't going through the work just to move the camera around. Come on, shawty. Nah. Okay. So, deep breath. Sure. All right, we're back. Lock in, Mike, lock in. So M is the height. That makes sense because it's the rows. So the height is M minus 1. So we're going to update that. And then here, I'm literally just going to calculate this again, I think. So actually, you know what? You know what, bro? C in this case is R. No, C is the column above, which is Y. And X is R is X above. Okay. And then 2 to the height is 2 to everything in here. Okay. Height is passed in, so we're chilling. That's passed in, so we're chilling. That's passed in, so we're chilling. We're chilling. Okay. So we're chilling. But this is X. Okay. That. Sweet. Curse right. So, I mean, we're adding a column to both, or sorry, we're going to the next row in both. But here, oh, whatever. Here we're doing Y, X, and then, yeah, I'm not going to think too hard about the indexing. I'm just going to use what they gave me, guys, because, like, yeah, I'm lazy like that. Okay, that should be right. So now let's code it. If node is null, what are we doing? So this is a void function. So we just like return and not do anything, I think. Or X is, oh, you know what? All right. I'm doing this. Bro, I love my global variables. I'm not even gonna hold you. I love me a good global variable. So, because when you pass in like 5, 6 parameters, that stack becomes chunky, dude. It's not good. Or X is greater than M, or Y return. Okay. Okay. So now we fill in the cell at the current coordinate. I got you. Say no more. X, Y equals node dot ow. Oh, wait. No, I lied. Because wait, oh no, guys. Oh wait, okay, hold on. I just noticed 2 things. One, we can't pass this in. We need to convert it to a string. Convert to a string. Second of all, we need to fill everything. We need to fill the grid with like blank strings. So yeah. What's the best way to do this? I'm thinking, is this the way to do it? Oh, wait. arrays. Yeah. This is good actually. Dot fill. For each row, we fill the row with empty strings. Oh shoot. Is that right? I think wait, I actually think I cooked just now. I think that's right. LeetCode will definitely let us know, that's for sure. So this when you convert to a string. So we have an integer. We want to make it into a string. What do we do, chat? What do we do? There is a function which I keep on my cheat sheet, which I will be now looking at. String methods. Fellas. It is not exactly telling me. So I'm going to Google it. How to convert a string into int in, that's not what I meant, an int into string in Java. Java, please, string.value of integer.toString. Oh. Apparently, string value of int. Oh. Value of value string dot value of, right? Yep. Okay. We're still cooking. And now update the grid on this. Uh-oh, what did I just do? Node dot left. X plus 1. And then, oh boy, y minus integer math.pow to be height minus, oh god, guys, I don't like this. I'm getting lost in the sauce. Minus x minus 1. Yo, give me a Grammy for that performance. All right. Update grid node dot right. What did I say? Oh yeah, it's still x plus 1. Plus. All right. That might be good. I might have cooked. I'm gonna be happy if this runs first try. Maybe, oops. Uh-oh, I just realized we need to convert the grid to an array list of strings, which I'll be Googling, because how to convert an array list of array list. Convert Googling, use the split. this isn't what I want. Hold on. Ay. Fellas, I'm using ChatGPT to write me for loops. That's how lazy I've gotten. Write code in here that converts grid into array list of string. Ellis, I gotta learn Python. Like, I know the basics, but I gotta learn how to do data structure like LeetCode and Python, bro. Because honestly, I can't take many more of these for loops, bro. Okay, so this code appeared magically out of nowhere. Basically, this is the result. For each row in our grid, we are adding it as a new array list using this function. It converts it all good. All right, let's give it a spin. Oh, yeah. It's not. I mean, it's more concerning if it worked. No. Okay, Mike. I see you. 94% first try. Oh yeah. Oh. O'Reilly Auto Parts. Bro, I just cooked on that one. LeetCode medium. I eat those for breakfast, all right? LeetCode easies. We don't even do those on this channel. Actually, we probably will do some. But get those out of here, all right? Man, I'm a LeetCode machine, all right? Don't try me, all right? Oh, yeah. Man, it's getting litty up in the city. Hold on, my boss is texting me. Hold up, that is not great. Never mind. I'm gonna stop. Bellas, that was a W. I won't lie to you, that was a big W. And you know what? I'm gonna end it there for today. All right, because this is the first episode. All right, I don't want to go too much over an hour. No, I'm not gonna get crazy yet. I'm gonna end it off on a positive note. If you enjoyed this video and you're watching it in the near future when I don't have 0 subscribers, please drop a like. Support your boy. Support the Patreon. Follow me on Twitch. Neither of those two I have, but I appreciate the thought. And yeah, your boy's gonna be a LeetCode god in no time. And you know, sometimes I struggle to find the lack of motivation, but when I have people supporting me and you know, struggling the way I'm struggling through these problems, listen, we're all there for the ride, and it motivates me more. And yeah, it's gonna make me look forward to do more of these. And yeah, take care, everyone. Thanks for watching. If you made it this